Hello everyone, Mr. Fawcett here, and we are back with another AP Calculus lesson. In today's lesson, we're going to continue with our discussion of area between curves, but in some of these questions, the top and the bottom function are not going to stay consistent over the entire interval. They may switch, right? So the bottom may become the top, or maybe we throw a third function in there. So we're going to have to be modifying these integrals to fit the specific situation, but we're still going to be carrying over a lot of the concepts that we've talked about in the last two lessons. And in this lesson, we may have to choose whether it's best to set up our functions in terms of x or in terms of y, based on the efficiency and the ease of which our integrals would look like based on whether they're x or y, or rather in terms of x or y. So to get you thinking, take a look at this problem right here. I have three functions on this graph, and I want you to figure out the area of that black shaded region. I do give you the actual functions down below. They're listed here. So I want you to pause the video and see if you can break apart this shaded area, see if you can write an integral or a set of integrals, or a sum of integrals, or a difference that would give you the area of that black shaded region. You can use your calculator to evaluate, and I do want you to try to evaluate. See what you get, and then you'll come back and you'll see if you're on the right track or not. Okay, so I think it's clear that we should split this integral up into split this area up into two separate areas. So we're going to be looking at the orange shaded area, and then we're going to be looking at the pink shaded area. And that's because at this value of a, the top and the bottom function change. Right? For the first interval from 0 to a, top function is green, bottom function is blue. Over the interval a to 2, well, the top function is the red and the bottom function is the blue. So essentially, our integral is going to look something like this. The area is equal to the integral from 0 to a of h of x minus g of x, top minus bottom. Going to be integrating with respect to x. I think that makes the most sense here. Plus the integral from a to 2. Now our top function is f of x, and our bottom function continues to be g of x. So f of x minus g of x, integrating with respect to x. Now you'll notice we have to figure out that a value. So we have to find the intersection point of the green and the red function. To do that, we could either use a calculator, we could do it by hand. Turns out the green and the red function are the least complicated ones here, f of x and h of x. So f of x equal to h of x. I'm just going to do it by hand because it comes out nice. 2 minus x is equal to the square root of x. If I get everything on the right-hand side, 0 is equal to x plus the square root of x minus 2. And if you see that, or maybe you see right away that x needs to be equal to 1 here for this to work. If you don't see that, go ahead, just punch it in the calculator, graph it, and see where the 0 is. You're going to get that 0 at x is equal to 1. So our a value is 1. I'm just going to come over here and switch out my a's with 1s. So 0 to 1, 1 to 2. You're then going to use the calculator to evaluate. I'm not going to rewrite everything, but if we do evaluate, we end up getting about 1.5833 for the orange area. That's going to be h of x minus g of x, that integral. We end up getting about 0.9167 for the pink area. And if I add those two together, we get approximately 2.500. Again, I'm rounding to 4 decimal places in the middle of the problem because I want to round or truncate to 3 at the end of my problem. So area is approximately 2.500. Okay, so we're going to look at 2 examples here. One where we're given a graph, or graphs of the functions, and one where we are not given the graphs. We're just given the algebraic form. We're going to start with the graph form. So this says, let f and g be the functions defined by f of x is equal to 1 plus x plus e to the power of x squared minus 2x, and g of x is equal to x to the power of 4 minus 6.5x squared plus 6x plus 2. R and S are the 2 shaded regions enclosed by the graph of f and g shown on the graph. We're going to find the sum of areas R and S. So while they do give us a graph, and that's helpful because we can clearly see that the top and bottom functions switch at whatever x value that point of intersection is. All right, so we already know we're going to have to write a couple of integrals here. What they don't show us is which function is which. So you don't show us which function is f of x versus which function is g of x. However, this would be a calculator problem. You're not going to be integrating here by hand. So you could just graph both of those functions to see which one is the f of x one, which one is the g of x one. It might be helpful to also, in your calculator, set up your window so that you're going from 0 to 2 for the x's, and you might want to go from 0 to 5 or so for the y's. Again, I'm just getting that from these points, which kind of, it'll give you a better picture of what's going on and which function is which. So pause the video, go ahead and do that. That'll tell you which function is which on your graph, and then we can go from there. So when you graph, you should see that this function right here is f of x, and this function right here is g of x. So over the first interval, g of x is on top, f of x is on the bottom, and then they switch. We do need to find that point of intersection. So again, do not try to do this by hand. You're not going to be able to. Go to your calculator, use the second trace feature, find that intersection point, and we'll need that x value. So pause the video, go ahead and do that. The x value of that intersection point is approximately 1.0328. You can go to more decimal places if you want, because again, our final answer is going to be rounded to the nearest thousandth. And I'm actually going to go to 5 decimal places here. Generally, you're safe with 4. Your final answer won't be any different. If you have 4 or 5 decimal places and you're rounding to 3 at the end. But there are times when it does change, so I'm just going to go to 5 here to be safe. We've done all the heavy lifting up to this point, right? The rest is pretty straightforward. We've done this, many times throughout the last couple lessons. The area here, and again, pause the video if you haven't tried to write this integral yet. Set of integrals, I should say, the sum of 2. Our first integral is from 0 to 1.03283 of g of x minus f of x dx plus the integral from 1.03283 to 2 of f of x minus g of x. Make sure you put those in brackets, dx. So that's our integral here. From here, you could go straight to the calculator. You can rewrite g of x and f of x in terms of what they actually are, or you could just, because they are defined up above, you could jump straight to the calculator and give a final answer. I would encourage you to work through these on your own, but we do end up getting approximately 2.004 as our area here. Okay, let's do one more example where the graph is not given. So we're going to have to visualize this on our own or use a calculator, etc. We're going to look at this problem right here. It says, what is the area enclosed by the curves y equals x cubed minus 8x squared plus 18x minus 5 and y equals x plus 5? Well, given our answers, right, those are certainly rounded or truncated. So we are going to be using a calculator for this problem. Now, first thing I would do if it's a calculator problem would be to visualize using your calculator what the functions look like. So pause now, enter those functions on your calculator, and try to get an idea of what's going on. Do they have multiple areas between them, right? Do they intersect just once, or do they have multiple intersection points, 2 times, 3 times? Try to figure out what's going on before we look to set up an integral. Okay, so if you just use the Zoom standard window, negative 10 to 10 for both x and y, you can actually get a good idea of what's going on. The linear function right here, that looks something like this. And the cubic we have looks something like this. So we do have 2 different areas that we need to find, right? These intersect 3 times, and we have two areas that we're going to sum together. So we need to find 3 intersection points, right? We need to find this x value of that intersection point, this x value, and this x value. So that's our next step. Pause the video if you haven't done so already. Find those x values. We'll go to 5 decimal places for all 3 of those, and then we'll look to set up our integrals. And I noticed it around to 5 decimal places. Turns out I forgot what the intersection points for this problem were. They end up being whole numbers, which is nice. So our x values here are 1, 2, and 5. So we don't have to worry about all those decimals. This will make it nice. We do need to know which is our top and which is our bottom function over both of these intervals, right? We're going to be going from 1 to 2 and then from 2 to 5. This one's pretty easy, right? Because we should, again, know what a linear function is. So we know that our red is our top, or red is y equals x plus 5. Top for one of the intervals, and green is going to be, I'm not even going to write that out. I'm just going to box it in green. So red is our bottom for the first interval, 1 to 2. Green is our top, and then they switch for the second interval, end integral. Pause the video. Go ahead, write out these integrals. And then evaluate them using your calculator and see what answer you get. Okay, so first integral, to find the pink area, we'll say area is equal to the integral from 1 to 2. Green function is our top. So we've got x cubed minus 8x squared plus 18x minus 5 minus the quantity x plus 5 dx. To find our blue, integral from 2 to 5, all we're doing is switching. So we have x plus 5 minus that entire quantity of the other function. So if I can squeeze it in here, dx, that'll have to do. If we evaluate this using a calculator, we do end up getting approximately 11.833. Okay, that is going to do it for this video. We'll do the rest of the problems in class. Some of them are a bit challenging. We kind of did some of the basic ones, one with a graph, one without. Feel free to take a look at the other ones if you want, start thinking about them. but we will have time to work through those during class. As always, enjoy the rest of your day, and we'll look forward to seeing you next time.